Hello, this is Farhad Fallah from Alec Company. In this video, I'm going to show you how to use HES-DVM on the AWS cloud to partition and prototype an FPGA design into one of Alec's multi-FPGA prototyping board. I've already transferred my project files into my instance machine using FileZilla, and I'm going to use it to run the compilation and prototyping. There are two options to run HES-DVM on the cloud. The first one is to use the terminal and source the settings, and the second one is to use the HES-DVM icon on the desktop. I'm going to use this icon and double click on it. It's going to ask me about license file key. I've already entered it. I click OK. Once HES-DVM is open, I need to create a new project. I go to File, New Project. It's going to ask me about the project directory. I'm going to create one directory under HES-DVM design folder. I call it HES-Proj. Second window is going to ask me about the technology. The board that I'm using for this video has Xilinx Vertex Ultra Scale. There are different modes to HES-DVM like co-simulation, emulation, in-circuit emulation, and prototyping. The only available option on the cloud is prototyping mode. And also I'm going to generate a generic architecture netlist. Click on OK. Then I need to create my library, working library. I click on library. I say a new library and a logical mapping to it. You can name it anything you want. I choose the default as work library. Click on OK. Now that we have the working library created, we need to add the source files and do the compilation. There are two methods to do that. The first one is using the GUI. I go to Tools, I choose Compile Files with Options. It's good to know that DVM provides industry-proven HTL compiler that supports the latest VHDL, Verilog, and System Verilog standards. Here in this window on the left side, I can choose the source file, and on the right side, I can select any additional compilation options, such as VHDL or Verilog standards, or defining macros or any other source library directories. So for this video, I'm going to show you one source file and how I compile it. I choose this one, click on Compile, done. Under the work library, I can see the file that I just compiled. The second method is to use a .do file. A .do file can be prepared by Tcl scripting language, and it is supported by DVM. I've already prepared one .do file. I open the file, DVM dashboard.do. One of the features that DVM offers is that we can select any commands that we want to run in a .do file. For example, here I can just choose some of the files that I have here to only be compiled and run. In DVM, we use hcom command for compilation. If you want to know more about any commands in DVM and the console, you just type name of the command and -help. It's gonna give me any information I need about this command. So for this design, I choose the lines that I need to be compiled. I go here and choose evaluate selected text files. So if I go back to libraries, I see all the source files are added here for my design. Now that compilation is over, the next step is elaboration. To run the elaboration, I need to file the top module. The top level includes the user's designs prototype top level module. I find it, right click on it, click on elaborate. This window, I click on OK. I just choose the default value. It's going to take a little bit of time. And then we're going to see the window which has the board information on the right side. On the left side, we get the design structures of our design. We see all the ports, signals, underneath, and then we have the console and instance information for our design. Now in this step I need to set the prototyping board that I'm going to use for my design. To do that, I go to Design, Set Board, and the hardware platform I can either use a custom board or the ALDEC prototyping board. I'm going to use ALDEC for this design. Name of the board is going to be HES UltraScale 1320 BPX. This board comes with 3 FPGAs, and then because we are using it on a backplane, we have 4 of these boards connected to each other. I just want to use one of them, so I deselect BCD and click on OK. So on the board information window, we get detailed information about the board, about single-ended interfaces, different number of differential interfaces, lookup tables, registers, block RAMs, URAMs, and DSP blocks on this board. Okay, so far we did the compilation and elaboration, and also we set the prototyping board. Now the next step is to do the synthesis. DVM uses synthesis tool which is provided by ALDEC company. To do that, I choose Design, I click on Run Synthesis and Analysis. This is gonna take a little bit of time depending on how powerful your instance machine is. So I'm going to pause the video here and get back once the synthesis is done. Alright, the synthesis is over and we generated 183 netlists. The next step is to add the design to HES board. To do that, I go to Design, Add Design to HES. Once the design is added to HES board, one clocks tab will pop up, which includes all the main clocks for our design. One of the features that DVM provides is to convert gated clocks to clock enable, which is going to be very hard to do manually. To do that, we just click on Run Clock Conversion. We can also set the high time and low time to define a period for a clock. These times are going to be in nanoseconds, so I define this as 20 nanosecond. Automatically I get a 40 nanosecond period. I go 40 for this one, for this one, the 100 for the JTAG clock. Also we get to see the CDC delay, which is the max delay constraint for implementation, and the worst case delay, which is going to be defined later in the process. Once the clock conversion is done, the partitioning tab will show up. Under this tab, we can see how many resources are used by each partition, how many flip-flops, how many lookup tables, how many memory blocks, and how many DSP blocks. In this table, we can see the design hierarchy. If we open each module, we can see how many resources are used by each module under the P0 partition. Also, it allows us to assign FPGAs to each partition and monitor inter-partition connections. DVM enables us to create new partitions for our design. For example, under the design hierarchy, I can choose RV top, my top module, and move it to a new partition. I can just use the default name as P1 and click OK. So what I say is that all the RV module and all the resources are moved to the partition number 1. On the top window, we see another partition is created as P1, and we can see their interconnections between P0 and P1. How many connections we have? We have 96 from P1 to P0, and then from P0 to P1 we have 149, total of 253 connections. Now that we created new partitions, we have P0 and P1, we need to add each partition to FPGA. To do that, I click on the partition, I go to select FPGA chips, choose FPGA number 1, for the second one, choose FPGA number 2. Typically, in multi-FPGA prototyping boards, there are some special global nets used for clocks and resets. They are routed carefully and should be length aligned to get the best performance. It's a good practice to use these nets as global clocks and resets for our design. So in my design, I go to design ports and I'm going to use core clock and connect it to global signals on the board clock 0. Once we are done with partitioning, we need to go to the connections tab to do the interconnection between two partitions that we have. HES-DVM does this automatically for us. To do that, we go to connections, auto connect, and also we need to connect the interconnections to the pins on the board. We do auto pins. Even though the interconnections are done automatically, the design ports has to be connected manually using the pins available on the board. So for this design, I'm going to choose some of the pins that I have available on this board. Once we are done with interconnections and pin assignment, we need to run the validation to make sure all the connection and pin assignments are correct. Validate, it says validation success. If there is any pin which is unassigned or any problem in interconnection, is going to show up here for us. Right now, the last step remaining is to write the files and prepare all the files which we need to finish the prototyping. I go to connections, write files. In this window, I can just choose the default and click write. Now that we generated all the required files for prototyping, let's go over what we've done very quickly. At the beginning, we created a new project and a new library. We added the source file and ran the compilation using the .dofile. We did the elaboration and we set the HES board as our main prototyping board. We ran the synthesis and analysis. We added the design to HES boards. We ran the clock conversions and we created new partition and we transfer all the top levels to that partitions. We ran the auto interconnections and also auto pin assignment, and we wrote the main files. Once the files are created, we can go under the HES project, the project directory under the HES. We see two directories, that's P0 and P1. They include all the required files for prototyping, including the implementation.tcl, which can be used in Vivado to run the implementation and place and route. The main purpose of this video was to show you how to use HES-DVM on the cloud for design partitioning and prototyping. We will publish more detailed videos soon. Thanks for watching.